I've been writing all this stuff, though, just because you're asking, the way I've been writing it is I just steal some stuff from her and write some stuff myself. And okay.
Why do you always talk to Jackson on like it's not TV?
Because Jackson.
Because I don't know them.
Because Jackson, the circle.
Yeah.
Jackson. Yeah. I can't.
TV smart people. They have 25 kids in their geometry lab.
The circle children. Or
They are children of circles. All right, so we should be able to handle the square root of 845. Now, those perfect squares over there is basically what you have to pull out. You'll have a calculator, so pulling those perfect squares is not how I would approach it, but in a sense it is. So one of those numbers I'm going to be able to pull out. So if I take my calculator and I go 485, okay, and chances are you're not going to have that list memorized. You might have some of them. You might know divided by 9, that's a perfect square. But you probably don't have, what number did you just say? 289. You probably don't have that memorized. But what I would do is I would divide this by, I don't know, 15, okay, and see that that gives me a decimal. That means that's not going to be the one. So 13. Okay, so 13 worked. It's got to work how many times? Got to twice.
What do you mean? I'm so confused.
Okay, so what I just realized is if I can divide it by, if I can divide it by 13 twice, then 13 is a perfect square. In other words, this thing equals the square root of 5 times the square root of 13 squared. Okay.
Why don't you just find like whatever number that is? So if it divides by like 825 divided by 25, or just find one that it divides by, and then you just like put it there. Like
Okay, so let me.
50 is like 2 and 25.
So let me tell you the idea. All those are perfect squares because what? Why is 4 a perfect square? Twice, right?
Yeah.
The same number, the number 2. I'm not dividing it by the number inside. I'm dividing by a number on the outside. So if I can divide by 2 twice, then I know that it's made up of square root of 4. So let me re-explain this because I think I confused you with that.
Okay.
But what I realized is that I can divide this by 13 twice. Okay? And 13, I just guessed and checked, yes. And 13 twice is 196. So I can divide 845 divided by 169. I said that wrong. It's 5. So basically, this is made up of square root of 5 and square root of 169. What part of why are you saying what?
Okay, I understand, but why don't you just start dividing by all those answers and then?
Okay, my point is, and absolutely, if you work in radicals and you want to write that list of numbers down, then you can do that. So my point though is that if you don't write those down, you probably don't know 169, and that one you might, but you don't know 225. You don't know 256. Maybe you do. I don't know. But I don't. But if you write those down, absolutely. Let's just start dividing by those numbers in the radical. Okay? And it's guess and check. 285 divided by 144. That didn't work. 285 divided by 196. That didn't work. So when you figure out what does work, that's what those are made out of. So square it. Sorry. I'm 289. You divide by any of these until you find which one works. And once you realize what works, now that I know that square root of 5 and square root of 169 is what this is made out of, and I know that this is a perfect square, I'm going to write this as 13. I'm going to write this as 13 square root of 5. We clearly need to do more work on this, okay? I was trying to do a quick 10.
Why can't we just watch it?
Why can't we just do square root of 845 equals and then find the answer?
Because that is the answer this is the answer I'm going to accept.
Can you give us another random number and then we have to
Sure.
solve it?
You want to try one?
Oh, I was trying to get.
He's gonna take your break.
Well, I don't care, but I'm getting.
There you go. Square root of 1,575.
You gotta give us like the repeat the number. Oh, well, it's right there.
Hey, me too. Me too.
I know, right? Oh, yeah, I got it. Oh, you guys already have it. Oh, I was entering the wrong number. That might.
What's 100 times 100?
I mean, there's definitely luck involved. If you pick the right number first off the bat, then you're quicker that way.
It is 10,000.
I'm smart. Really smart like it.
100 times 100. Let's do.
Yay!
Let's do 20
It has to be
times
the
20.
That's
20 times 20, that's 72,400,000.
That's 400.
If you're not using those magic numbers over there under the radicals, then yes, you gotta do it twice.
Wait, we have to use those numbers?
No, just figure it out.
I'm smart.
Oh, I'm so dumb.
39.6862697767. That's the answer you want. I know.
Did you find this, Andrew?
Yeah.
Okay,
I just felt it just then.
In the arts.
That wouldn't be a 7 because this. So we have to take that third one.
Did you find your solution?
Yeah.
Oh, is it, Mark? You can't divide it twice. That's 15.
It's not 15.
Yes,
It's not. I just did it. Yes, it is 15.
Whoa, relax.
Yeah.
Children are so.
I tried it and it works.
I don't know if we could simplify this number any farther though.
Wait, do we divide without the radicals?
So how do I get the other number?
Oh my god, I'm so dumb. I really realized to do that.
So let me show you how I would do this. I'm doing this as if I don't know those numbers up there. What are we doing, Jonathan? Was I interrupting you?
Yeah.
Oh, okay. So 1575, the way I would do it, because I don't have any of that stuff memorized, that my memory is awful, I would divide it by, I don't know, 14. Realize that doesn't work. Divided by 15. Wow, I got lucky. That one gives me 105. Only lucky if it does it again. It does. Okay. So it says 7 up there. So that means that I know that this is made up of 15 times 15. Okay, so 15 times 15 times 7. Well, the reason that all those work over there is because, and some of you might like to think of it this way, that this is 225 times 7. The square root of 225 is 15, and that 7 is what's left over.
Yep.
I'm sorry? At the end. Okay, I want to make sure we have time to get this done, and I was hoping that we'd have time. That was just a taste. We'll spend more time on this. Okay. So, proving triangles are congruent we have some rules: side, 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 side angle, side. Okay, HL and so forth. Proving triangles similar. Do me a favor and circle this word right there. I'm sorry.
7-2. They were asking me like angle similarity thing, and I have no idea.
Okay, well, let's talk about this, and then hopefully that clarifies that. And hopefully tomorrow we get a good chunk of time to ask questions. So this is similarity, and a lot of times you'll see this written as SAS, and then this squiggly line for similarity. So go ahead and just put that over there. Or you might see side, 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 similarity. Or angle, angle, similarity. And then CSSTP, corresponding sides of similar triangles are proportional. Okay. Don't really have to memorize that. Okay. So don't worry too much about that. These three you kind of have to know. Notice that it doesn't include angle, side, angle. Okay. Because angle, side, angle would actually be what? Why don't we need angle, side, angle? It's already represented up there. What is angle, side, angle represented as?
Side angle side?
Nope. If I give you, it's angle, side, angle is the same as angle, angle. Because all you need is two angles. All you need is two angles.
Yeah, I get it.
What about AAS?
What is it? AAS. You don't need AAS because angle, angle takes care of that.
Oh, you're screwing with my brain.
Why didn't you just tell us?
He's already done that a long time ago. Yeah.
Well, he does love.
You want me to tell you everything before we started?
Exactly.
Tell us everything we need to know before we actually know it.
In this little box, she wants us to draw.
I made a heart on my.
I want you to draw that, and it's weird that this side here is going to be similar to this side here. And this angle, I know, this angle and that angle are not going to be similar. They're going to be what? They're going to be actually congruent, and that this side here is going to be similar to this side here.
What does it mean by?
We will get there. Okay. And then this one here, you're going to have an angle congruent to an angle, and then just one more. Why don't you need the third one?
Because there's no other angle. Because angle doesn't.
If I give you two of the angles,
Third one, it's gonna add up to 180.
it's going to add up to 180. So that third one is automatically going to be congruent if two of the three are congruent.
Wait,
Okay.
can it be used like two sides?
Two sides, no. You have to have three sets of sides. Okay. And this will be more clear as we do some of these problems. All right. So looking at this first question, I think this will clarify something. Okay. Determine if the polygons are similar. So we have that this angle here is congruent to that angle. That was given. Are there any other information that we know?
BCA and YCX is the vertical.
Thank you, Andrew.
Nice job.
So those two are congruent because of vertical angles. Okay. So if so, write a similarity statement and name the postulate used. So the postulate that we're using is what? We're going to use angle, angle, similarity. So we write it like that. That's the postulate. And the statement is triangle ABC is similar. And we got to be careful because we got to do the corresponding angles and such. So angle A, I wrote first, corresponds to which angle on the other triangle? Y. XC. Thank you. Notice it's not congruent, it's similar. That means they're the same shape, just one's bigger than the other. Okay? Easy peasy strawberry lemonade.
I don't know, what
A
did you
piece
say?
of strawberry lemonade.
I thought
Strawberry
Easy
lemonade.
peasy. Okay.
I thought you said to eliminate.
Doesn't that sound good? Pants on fire.
I thought that I made up easy peasy lemon squeezy when I thought I made it up, and I saw it on a TV show, and I was really mad.
I thought I made up easy peasy strawberry lemonade.
I think you
Probably
did.
did.
I think you did.
But
I was
I
like, my mom was like,
eliminate
you did it. I was like, yes, I did.
What was it?
Easy peasy lemon squeezy. I thought I made that up.
So they like to write these in this kind of weird way. So I want to make sure that we write it in the same weird way. They like to say EF corresponds to what?
AB.
So they'll write it like this. It is a fraction.
What do you mean?
They'll also write, then they'll write, and you got to be consistent because I started with the big shape on top. I got to be consistent. So EG is related to AC.
Yeah, that one.
We got this into the weirdest math.
The angles, angle A is congruent to angle E.
Where are you writing this?
We do not need to do anything more than that
No fraction mark?
because no fractions we want the angles to be the same. We need the sides to be proportional. Okay? If one side's 2 times bigger, then all the rest are 2 times bigger. So let's do this. So this is 92.4 divided by 33. I kind of didn't give myself enough space. And this is 108 divided by 40. And I picked these kind of weird numbers so that you can't just go, oh, yeah, it works. What is 92.4 divided by 33? 30.8. So that's one part. And what's 108 divided by 40?
2.7.
I don't know that 92.4 divided by
Just 2.8.
2.8.
Yeah.
What do you mean?
Did you subtract?
30 times.
92.4 divided by 33.
Don't ask me what I
108 divided by 40.
2.7.
Does it work?
So is this similar?
No.
So we say not similar. And
Angle A is not even congruent to angle E.
it is.
Yes, it says 42.
Oh, I thought it said 40.
You're slow.
Okay. So this is super close to being similar. Okay. If I cut these out and had you measure them, you would tell me they were similar.
Why can't we just say proportional if they're similar?
Okay. So this is not similar. If this was a 2.8, I would have said similar by what?
By sine angle phi.
Good, but we can't. So we just say not similar. Do we write a similarity statement? Absolutely not. Okay. Move on to the next one.
Would this be side, side, side?
This is going to be side, side, side if it works out. Okay. It doesn't matter which shape you start with on the top as long as you're consistent. I like to do big over little myself. DF corresponds to AC. DF is 7.5 over 5, which equals 1.5.
All of them are.
What do you want to do with them?
EF, and you have to show this work over BC, which is 6 over 4, which equals 1.5. And then finally, AB, nope, ED over AB
Yeah.
Over, okay.
It's okay.
Well,
Over BA.
SSS.
So because these are all 1.5, we can say SSS. You got to put that similarity sign on there. I promise you I will take points off if you forget that little sign. I promise you you'll be frustrated if I take off because of that little sign. But if you don't put that sign on there, you're telling me what about the two triangles? That they're exactly the same, that they're congruent, which they're not. If they are similarity, write a similarity statement. So this is the postulate we're using. Then we're going to say triangle ABC is similar to triangle A corresponds to
EDF.
mm,
Wait, no, D, E, F.
thank you, DEF.
There's one kid in our school named AB, and for Mr. J's class, they had to,
I hate her because the teacher
spell their name in the alphabet.
I would totally be a fed if you make me.
Did you hear about that kid named ABCD?
Yeah, I know AB is not the C.
He was ED deaf.
That's not it.
Dumb.
No.
I mean,
What did I say? Somebody named their child ABCD.
well, there's this kid named
E?
Is there a pun to that? Like,
No, it's true.
I thought it was a
Oh,
joke.
I think it was gonna make a joke and be like.
I don't make jokes.
It has 1,000 letters.
But then it's just like.
Oh, yeah, I just saw it.
Why would anyone like that?
Why? Then he got.
ABC, come here.
They're gonna be screwed when they get into.
They love to give you questions. They love to give you questions that are kind of confusing. When you first look at this, you may think that this is the first triangle we're working with and this is the second triangle, but that's not true. They said PSQ. PSQ is what? The big triangle. So PSQ
Minus RPQ.
has a side of 18 here. And what is the side on the bottom? 27. And triangle RPQ
Oh my god, it is. Wait, maybe it's not.
has side of 12 and 18 here. And the other thing that's kind of bad,
The angles are congruent though because it's the same thing.
what angle?
The Q.
Angle Q is going to be congruent to angle Q. Why is angle? Okay, so the other thing is the way I drew this doesn't help us out because I did a really bad drawing of it. But we gotta. I think it might be easier if we rotate this because 18 doesn't correspond to 18.
why does that matter? Go ahead, never mind. I need to stop asking questions.
So if I said this side matched to that side, its scale factor would be what? 1. And then I would say this scale factor is not 1, therefore it doesn't work. Okay. So if I'm careful here, it says PSQ. So I should draw the second triangle in that order. P should be on the top. P corresponds to R. So I should put R on top. S corresponds to P. So I should put P here. And Q corresponds to Q. Okay, so I pointed up here. Okay, so P is related to R. Because this is what it's asking me to prove. Because there isn't an S in the second triangle.
Oh, they do. Not you. I think they do that now. No, they don't do it. Oh my
So we still know that this is congruent. RQ is 12 and PQ is 18. So I kind of don't like this drawing. I think it's going to confuse us if we use it.
You wouldn't even be on that side.
Yeah, it would.
That literally.
It wouldn't. Yeah, because she was on the other side.
There you go. Kind of.
Wait, the end? Oh, never mind.
Wait, that's like a 90 degree.
Do they have to do a statement?
This is why.
Yeah, I'm just waiting for people to be more at peace.
Don't get it.
We okay? Fish? What's wrong with your face?
Yeah, I'm talking to
Okay.
your
Huh? That's me?
Sure.
If you guys could see the looks you guys give me. I know, you're the best.
Yeah, I don't give you one.
I know, because you're asleep
All
half
you
the
do
time.
is yell at them.
No, I am not, Mr. McConnell.
All right, so write this proof. What information do we have to give?
That,
P is the same as R.
that PS. Wait, what? That PS2.
Okay,
What?
angle Q, as the first one I heard that was correct, is congruent to angle Q. How do we know that?
Because of divot. Reflexive.
Reflexive property.
What?
What's your reflexive? Reflexive works for angles. It's not reflexive, it's
Because reflective
reflective.
was equal to itself. Right?
Yeah. Hey, Dot.
Yeah.
Um,
That's what she's good at.
She makes everything good.
If I backtracked and changed the question and said, just tell me which postulate you need to use to show that these are similar, what postulate would you use? It would be side, angle, side. Say the last word.
Similarity.
So we're going to end up using side, angle, side, similarity. So we need to say something about a side.
27 is not related to 18.
We need to say something about an angle.
What do we do?
We need to say something about a side.
It's something about like.
Now let me ask you, let's take a step back for a second.
Yeah.
Let me ask you this question. Is expressing your discomfort for not understanding immediately something that you should put out in the world?
Yes. Yeah.
Okay.
No.
Maybe, maybe not. Okay, so I get that we don't get it right off the bat. So I've said something about the angle. Check. What do I say about the sides? This is where it gets kind of weird, but go ahead.
Do we need to use Pythagorean?
We do not. Simpler than that. We just need to do the division thingy. And this is what we're going to do. Let me just show you. I'm going to say PQ divided by what?
PQ.
PQ divided by RQ.
RQ equals, watch this, SQ divided by PQ, which equals 1.5. So, strange thing about this one is in one statement, I'm going to say something about both sides.
Can I ask how you added the SQ in?
The
There was
SQ.
no SQ, exactly.
I'm sorry?
Because you went from doing PQ and RQ to all of a sudden saying Oh, hey, let's throw SQ in too.
Exactly.
So how do you get
No,
that?
you deleted that one. You deleted that triangle.
I deleted the one I crossed out.
No.
SQ isn't in there.
Yeah.
Wait, there is
Oh.
an SQ in there.
Okay.
Okay.
Oh, another one for PQ. Doesn't make sense.
Which question?
This question is everything.
No, like, you said that for triangle PSQ, you have to delete the S and put in another triangle.
I'm sorry, say that again.
For triangle PSQ, you said that, you had to get rid of the S and then put the P in.
What I said about, please stay with me. What I said about PSQ is that that one's fine, but that I didn't like the way I drew PRQ, so I wanted to redraw it so it was in line with the other one.
I thought we just put division for a reason. That's your answer. That's your
Okay. So what would be the reason for this?
Okay.
Division property.
Similar sides. Okay. And the weird thing about this is we've just shown that those sides are done. So these proofs in some way are a lot shorter than the other ones. So what do I say next?
Are we doing Can you put a check mark real
PSQ
quick?
is similar to triangle RPQ. They're gonna break. You have to understand that.
If they both equal, I'm sorry, because
I don't know how it looks like.
that they all equal each other.
They're not, and that's what's weird. You're not saying they're equal to each other. You're saying that they have the same scale factor.
I was really confused on the homework. I just gave up the Baxter trying.
So it is.
Yeah, last night's homework, I got the national practice, so I did the practice and problem solving. I could not do that.
Let's get this last problem done, and then we can hopefully have a little bit of time. Okay, so to kind of redo what I did on that last one, we're going to go ahead and draw triangle A. I like to redraw these A, B, or AIB, or ABI. Okay, and then if I want to draw the other one to show what's related, I would want to write, I would basically draw the same triangle because they're similar, except I'd make it bigger. And instead of writing A, I would put what at the top?
Oh.
Okay, where are you getting that letter from, Mark?
The other triangle.
Okay, so A corresponds to what? L.
Oh.
Do you see that?
And then R.
And then instead of B, I'm going to write, well, it is B. And then instead of I, I'm going to write R. So if I wanted to see those two triangles broken apart, that's how I would suggest you do that. With all that being said, you kind of don't need to do it on this one. I'm listening.
Okay, so since the lines are parallel,
Okay.
that makes AL a transversal,
Okay.
which makes angle A and angle L congruent
So angle L and angle A are congruent.
by alternate.
Okay, it sounds like he's just starting to write this proof.
Oh no, I already got the answer.
So angle A is congruent to angle L because of what? Alternate interior angles.
And then angle ABI and LBR are congruent by vertical.
ABI and angle what?
The vertical.
LBR.
LBR because of vertical angles.
That means they're similar
AA.
by AA.
Triangle ABI is similar to triangle LBR because of Angle, similarity.
Question, did you have done angle I and angle R?
Yes.
You realizing I got it hard.
The funny thing is I learned this as angle similarity,
That's weird.
but you don't need that third angle.
I like it better than L3.
With all three, it just, it does,
I like two because then I can remember like, oh, angle doesn't work for like, yeah, congruent, but like angle works for,
Similarity.
yeah.
all right, so individually, you can work on the group quiz. Tomorrow, I'm going to put you in groups. Okay. And you're going to turn in, anyways, we'll explain that tomorrow, but be ready to have that, share with your group, have that done. And then, yeah, and I'm going to assign your assignment here in about 10 seconds. So right now, I'd like you to work on that group quiz individually. I don't want you sharing with your group yet. I want you to do it first by yourself, or you're working on Pearson's. Okay, I'm gonna put the Pearson's on, or you can ask me questions about other Pearson things if you have them. Okay.
I have everything done except stuff that I don't